Hello, sir. We are Group 10 of Section M, and today we are excited to present our business analytics project. When we first saw this dataset, Inequality Education dataset from Kaggle, one question stood out to us. Does inequality in education come from the type of school you attend, or the grade you are in, or even the size of your classroom? To answer this, we used Excel for pivot tables and ANOVA and regression and built a dashboard in Power BI to bring the story alive. In this project, we explored education inequality data and understand factors that affect student performance and dropout rates. Let's take you through the story hidden in the data.
Our data set came from Kaggle and it captures key aspects of education inequality: average test scores, dropout rates, school categories, and student teacher ratios. When we started, our guiding questions were: do different types of schools perform differently? Does grade level influence dropout rates? Does student teacher ratio impact test scores? Now, if we think intuitively, most of us assume that private schools must outperform public schools, that dropout rates spike at higher grades, or that smaller class sizes guarantee better performance. But are these assumptions true? Let's see what the data has to say.
Coming to visualization with pivot tables and Power BI, to make sense of the raw numbers, we created pivot tables in Excel and built visuals on Power BI. When we compared average test scores across school types, the bars in our chart were almost identical, around 69 to 70% for charter, private, and public schools. So no school type had a big advantage. A pie chart of dropout rates across grade levels showed the same thing. Element in Power BI, our scatter plot of student teacher ratio versus test scores looked like a random cloud of points with no clear upward or downward pattern. So visually and through pivots, we saw the story forming. Outcomes seemed very similar across categories, but we needed to test this statistically. So now my friend will continue.
So now let's talk about descriptive analysis. So before running to formal test, we summarize the data, the mean, the median, and the mode of test scores very tightly, aligned and confirming stable performance. Standard deviation was small, showing little separate and skewness, and kurtosis showed the distribution was close to normal. And when we looked for outliers, only a handful appeared. This reassured us the dataset was consistent, but visualize and summarize can only tell part of the story. To go deeper, turned into ANOVA test. So here is our descriptive stats.
ANOVA helps answer, are the differences we see real or just random noise? First, for test score across school types, our F value was smaller than the critical value, and P value is 0.62, well above 0.05, meaning the differences in the test score were statistically insignificant. Next, the dropout rate across grade level, the p-value 0.20, again greater than 0.05. So grade level doesn't significantly affect dropout rates either. In plain words, school type doesn't matter much and neither does grade level. But what about the class size? This is where regression comes in. With simple regression, linear regression, we asked, does the student-teacher ratio explain test scores? The model R square was only 0.0016, meaning it explained less than 1% of variation. The coefficient was positive, suggesting a slight rise in scores with the higher ratios, but the p-value is 0.20 was too high to be significant. So statistically, student-teacher ratio had no meaningful impact here. At this point, after pivot, dashboard, ANOVA, and regression, our story was becoming clear. Now, none of the traditional assumptions, school type, grade level, class size, explain much of the inequality. Now, Jatin will explain insights from the dashboard.
So I will explain the insights from the dashboard. This is where our Power BI dashboard really brought everything together. So on our screen, 1 minute. First, I'll show you the dashboard. So you can see on a Wiki has compared the schools and the grades and ratios side by side. Interactive filters allowed us to drill down, but even after slicing the data, the picture stayed the same. Performance and dropout rates were striking similarly across categories. The dashboard reinforced and our findings visually and helped us to communicate and story more efficiently and effectively. Now I
So,
will
coming
say.
to inferences and implications. So, what do we learn from this analysis? School type doesn't drive performance. Public, private, and charter are almost the same. And second one is grade level isn't a major driver of dropouts. And coming to third, class size doesn't strongly impact scores. So now, why is this important? Because when we look at the data, we see that many common assumptions in education, like private schools being better or smaller classes leading to better results, are not always true. The implication is clear. If we only focus on these surface factors, we might miss the real issues. Data shows us that inequality in education is shaped more by things outside the classroom, like socio-economic conditions, family environment, and access to resources. So this makes the role of analytics very important because it helps us look beyond assumptions and understand the bigger picture. So my friend will conclude.
To conclude, our analysis shows that school type, grade level, or class size are not the main reasons behind education inequality. This is important because it reminds us that reading and interpreting data makes decision making easier and more reliable. Without data, we may rely on beliefs or stereotypes. With data, we can see the real story. Our recommendation is that policymakers and educators should not only think about structural aspects like class size or school type, but also focus on improving support systems such as family support, economic assistance, and access to learning resources. So, the key takeaway is that data doesn't just confirm or reject our assumptions, it guides us to make smarter evidence based decisions. Thank you so much for being with us throughout the presentation.